Welcome to a lesson with Dr. Powell. Let's take a look at an idea called modular arithmetic. Namely, we're going to take the integers and we're going to partition them, subdivide them up into different subsets. So first, suppose, now we can do this with any type of multiple, but let's just, for starters, do multiples of 5. We can notate this as 5 times the integers, because any integer times 5 will give you a multiple of 5, and that'll be all the multiples of 5 so represented. So why don't we do that? And then why don't we also have the idea, which we could write as maybe numbers that are 1 more than a multiple of 5, maybe numbers that are 2 more, numbers that are 3 more than a multiple of 5, and numbers that are 4 more than a multiple of 5. And these are our only options for integers. 1 more than a multiple, 2 more, 3 more, 4 more, or just simply a multiple. It partitions all of the integers. We can notate these sets in the following way. 0 bar, where this means 0 more than a multiple of 5. This means 1 more than a multiple of 5, 2 more than a multiple of 5, 3 more than a multiple of 5, and this means 4 more than a multiple of 5. Keep in mind that what if we wanted to do 6 more than a multiple of 5? Well, let's just take a look first for a minute. Well, so let's suppose we take multiples of 5 like 0, 5, 10, -5. Notice that if I take anything that's 1 more than a multiple of 5, like, like this right here, so suppose that's 6, and that's in the set 1 more than a multiple of 5. Notice that it's also 6 more than a multiple of 5 because 0 is a multiple of 5. So it's in 1 bar, but it's also in 6 bar. In fact, you should see that 1 bar is equal to 6 bar. Anything that's 1 more than a multiple of 5 is also 6 more than a multiple of 5. Anything that's 6 more than a multiple of 5 is also 1 more than a multiple of 5. So we have a nice way of notating this. So anytime that we have something, for instance, we can even look at 11 bar. 11 bar is 1 more than a multiple of 5. These are the same. 11 more than a multiple of 5 is the same thing as 1 more than a multiple of 5. 21 more than a multiple of 5 is the same as 1 more than a multiple of 5. So we can reduce any number in this arithmetic. So this actually allows us to find out in which of these categories an integer lands. Does it land in this one, this one, this one, or this one? And we can do that simply by dividing the number by 5 and looking at the remainder. The remainder tells you exactly which of these categories it lies in. So we can just think 1 more than a multiple of 5 and label it like as so. And we can think about, and we can label each one of these sets in a myriad of ways, such as 1 bar is the same thing as 6 bar, or 11 bar, 21 bar, and many other things. Okay, this allows us to we can do some neat arithmetic here. For instance, if we're working, we're partitioning the integers by multiples of 5. So this is notation for that. And we can read this as z mod 5, or mod 5z if we want, z mod 5z, or just simply mod 5. So we split the integers up by multiples of 5. So that makes a partition of 5 different things. Multiples of 5, 1 more, 2 more, 3 more, 4 more. Then what we can do is we can maybe do some arithmetic. And under the skies, we can use bar notation if we want. We can say 23 bar plus 2 bar is equal to, then we could reduce this and say, hey, this is the same as 3 bar plus 2 bar, because These two guys are the same. And then we can use the idea that actually applying the bar is actually a merge. Notice how we partition the domain. It's like into subsets. That's like making a fiber box diagram. That's like making a function, even a merge function, a function that does nothing but merge, no relabeling. It just kind of clumps things together in that sense. So we have this nice function. Now this function actually, it preserves the operation of addition very nicely. So that means that we can add in the domain or the codomain and get the same result. So we may as well just change this to the domain where we know how to add in just regular integers. So we put everything before the bar symbol, since the bar symbol is kind of like a function. So put it before. So these bars, very nice. We can move the addition inside of them or outside of them. That's function preserving structure idea. And that's going to be equal to 5 bar, which we know is the same as 0 bar. So we have this nice arithmetic. 3 bar plus 2 bar is 0 bar. So this is arithmetic in Mod 5. Thanks for watching.